Hey, hi everyone. So today I'll discuss one of the most exciting problem of system design, that is live streaming of emojis. We all would have seen the IPL matches, and I hope you would have also seen one of the recently launched feature of Disney Plus Hotstar that you can share live emojis during the live matches. So without wasting more time, let's get into it. All right, let me start with my quick introduction. My name is Piyush and I do have total 10 years of experience in software industry, currently working as a senior software engineer in Microsoft. Let's start with the design discussion now. So what exactly we are building today is the live streaming, emoji live streaming, high level system design. And for our reference, I have taken these two screenshots. If you see, this is the screenshot of one of the live streaming cricket match live streaming application where you can see we have multiple emojis here. And for example, millions of people are watching this match. They can click on these emojis, and what other people are watching this match on this application live, they can also see the emojis reaction live. This is the feature which is not only available on the live streaming cricket live streaming application, but also we have seen such kind of um, such kind of live emoji reaction on Teams and as well as on Facebook. Now I'll start with the high level architecture discussion, and then I'll discuss about how to implement this using Azure services with the live demonstration. This is the high level architecture. We see users, these are the users seeing match online, and all the green interaction you see is the interaction users are doing with respect to the group they have joined, right? So for example, there are n users sending emojis, right? So they will join a group. They'll not join group themselves. This is the part of, or this will be done through the application joins a group, send a message to that particular group. When I say message, you can think of the emojis, right? I might use messages and emojis interchangeably. So when they join a group, whoever is sending emojis reaction to that group, all other users on that group would see that emoji. So I'll give you one example. Maybe you will be able to relate it in a better way then. So we create multiple groups in WhatsApp, and whenever you create group, you also add some people to that group, right? And whenever you broadcast any message to that group, all the users of that group, they actually see that message. So similarly, here we create a group. So group is created at the backend, and whenever a user comes online, the user becomes a part of the group. This is done through the application, and then whenever they send any kind of emoji, that emoji is actually published to that group. So all other users on that group, they also see the emoji reaction because they have joined that group. So this is what is represented through the green color. All the interaction happening in the group, this is done through the green color coding. So blue, all the interaction between user and the backend services done through blue arrow is because of we also have to do a sentiments analysis. So user not only send an emoji to group, but also an event is also sent to the backend PubSub service. So why we are using PubSub service is because we need to create a socket so that we also do a kind of back and forth communication between user and the backend service, right? So that's why PubSub service is being used here. And when we send an event, because we have to do a sentiments analysis, we pass on that particular event to the event hub through PubSub service. Why we are using event hub is because event hub is very scalable service which can handle millions and billions of events, right? So this is the reason why we are using PubSub service, because we have to create a socket connection between users and the backend service, and then whatever events we are getting through users, we have to do a kind of sentiments analysis. That's why we are sending those events to the event hub service, because event hub service is the service which can handle millions and billions of events. And those events through Event Hub being passed on to the Stream Analytics service. Why we are using Stream Analytics service is that because Stream Analytics service is the service through which you can analyze the live streaming data, right? Because we have to do a kind of sentiment analysis based on the emojis we are getting. That can be done through Stream Analytics service. So that's why all the events we are getting to the Event Hub are passed on to the Stream Analytics service. So the Stream Analytics job will collect all the emojis of every 5 minute window and will count all the emojis and find out which emoji has been used maximum time for that particular 5 minute of window. And once it gets that emoji, it will create one entry in the blob storage with that data. So if we see, this is the sample data for every 5 minutes. For example, 12 to 12:05 p.m. Uh, the smiley emoji was used maximum time. Maybe the count is 10 and the sentiment is positive. So we can see we have bunch of entries here to find out the sentiments per 5 minutes: positive, positive, negative, so on and so forth. Okay, let me reiterate the HLD once again. User sending to request one with the same reaction. First one to the group, second one to the event. Whatever reaction sent to the group, that is actually published to that group. Whatever users join that group, they get the same reaction back, and they also can communicate back and forth to that group. The second request sent to the event, which is sent for the sentiments analysis to the backend service, which is PubSub. PubSub service is used because we are using socket connections here. PubSub service pass on those events to the Event Hub. Event Hub is being used because it can handle millions and billions of requests per second. And then Event Hub passes on those requests to the Stream Analytics service. Stream Analytics service is used to do a sentiment analysis. It collects all the data per 5 minutes and find out which emoji is used maximum time for that 5 minute of window, and then create one entry in blob storage with that data. Okay, so before I start with the actual implementation, I have break down this problem into two parts. First one is the live um, streaming of emojis, which we have already discussed and represented through green arrows. So we'll create some groups using Web PubSub service, and some of the users will join that particular group. And whenever any user will send an emoji to that group, that emoji will be visible to all other users who would join that group, right? So live streaming of emojis, this is the first thing we'll discuss. And then the another problem is that the sentiment analysis, which we already discussed and represented through green arrows. So those users will not only send the request to the group, but also they'll send an event with the same emojis to the backend PubSub service, right? So when they would send, and whenever I say the users will send, that does not mean the user will explicitly send those event and messages. The backend service, maybe the mobile app or web service, will send those events and messages to the backend service, the PubSub. So when PubSub will receive those events, it will send those events to Event Hub and so on and so forth for further sentiment analysis. All right, let's start with the demonstration now. So first, we'll see how can we create a service for live emoji streaming. So these are the steps I'll follow to create resources in Azure and to demonstrate this live streaming of emojis. So I'll create the resource group, then I'll create one resource of PubSub, Web PubSub service. Then we'll generate the access URL. We'll create IPL group there. I mean, because we have to create a group and all the users will join that group. So we'll create one group, and then this is a link provided by Microsoft where you can check and send messages to the created group inside Web PubSub service. And then I'll open multiple instances of this service. We'll have 2 3 users. I mean, one instance will um, will represent one user. So I'll open four instances, and then three instances will act as three users, and the fourth instance would look like this a user who is watching or on live to that stream and would see all the messages emojis posted by these three users. So let's get started. So first of all, I'll have to create a resource group. Let me let me create one resource group, emoji uh, demo. Let's review and create. Resource group has been created. Let me create one PubSub service resource. Let me create one PubSub. Check with emoji demo. Let's enter the resource name, emoji PubSub. Let's review and create. It's validating the request. Okay, the validation is passed. We can create PubSub resource now. Let's click on create. We can go back to the resource group. It's creating the resource. It will take some time to create the resource. Let's wait for some time. So emoji PubSub resource has been created. Let's create the access URL with the group. Let me create one settings, keys, my bad. So this is the URL which we can use to send emojis to a group. So we have to create groups as well. Let me create IPL group. Let me create IPL group, and then let me copy the URL. So I have already I already have one. I have already opened three instances here, which will act as a three users. We'll paste connection there. We'll connect to that URL, and then we'll join the IPL group. So this is the first user which has joined this IPL group. So as there would be two more users. IPL is the group, and there would be another user joining the group. IPL join. So there would be one user, the fourth user, which will join and won't post any kind of emoji, but we'll see all the emojis coming in, right? Let me go back to, okay. So I have to use some emojis, right? Okay, let me paste the emojis here. So this user is sending this emoji. Okay, so the user who is live on the stream can see the emojis posted by the user one. Maybe another user can also see that emoji, because that user two is also the part of that that group. And if I come to the third user can also see that sad emoji, right? If I send another emoji by another user two, we can see that all users can see those emojis. So maybe this one, if I send, see, every user can see the live streaming of the emoji. I think this is the demonstration of creating a resource of Azure PubSub service, and creating groups, and users can join the group and they can have live streaming and can send messages to the group. Okay, so let's start with the demonstration of the emoji sentiments analysis. So these are some of the resources I'll create. So PubSub resource is already created. So we have to create an event hub, because PubSub will send events to event hub, and then event hub will further send those events to Stream Analytics. Stream Analytics, we have to create a Stream Analytics resource, and then Stream Analytics, whatever it will analyze through the streaming of emojis, it will send that data and save that data to Blob Storage. So these 3-4 resources we have to create. I think let me go back to the portal and let's start creating resources. So first let me create the event hubs. So we'll use the existing emoji demo resource group. Emoji event hub name space. Pricing tier, let's take a standard one, and then review, and then we'll create it. Deployment is in progress. That will take some time to create the namespace. Let's wait for some time. Namespace has been created. Go back to the namespace, and we also have to create event hub. So let's create one event hub. Emoji event hub. Review and create. Let's create it. So I'll create required resources one by one so that we know and understand the flow of the resources. I mean, how exactly we have to connect all the resources. Go back to PubSub, and then we have to configure event hubs here. So let's add one. Click on configure event listeners, then configure. So we have to enable the system assigned identity first. So the identity has been created. Why we have created this identity? Because this PubSub service has to access Event Hub, and how exactly this PubSub service will access Event Hub is through this system assigned identity. So this system will provide access of Event Hub to this system assigned identity. Let's provide this PubSub resource access to the Event Hub to push events. Okay, add role assignment from here. Let's provide at the resource group event data owner. Let's see it. So now this emoji PubSub resource can push events to the event hub we have created. Since we have provided access to the identity, now let's connect this PubSub resource to the event hub. For that, we have to create the hub, right? So in Emoji Live Streaming, we created groups because all the users joined that group and they were seeing live emoji reactions through that group. And now, because we have to do a kind of stream analysis, and this emoji PubSub resource has to send, you know, streaming data to Event Hub. Event Hub connects to this PubSub resource through Hub. So Hub is the connection between PubSub service and the event hub, right? And whereas in case of live streaming of the emojis, we created groups, and through that groups, all the users were connected to each other. So let's create IPL hub, and then let me add event hub to this hub, right? Let's confirm and save it. Now we have to send events to this IPL hub, and for that we have to generate the link. Okay, let's wait for some time. It's in updating state. So the hub has been created. Let me go back to the keys and let me write IPL hub here. So once I type IPL hub, a link to send events to this IPL hub will be created. Let me paste that link here, and this is the client to send events to this IPL hub event link, right? And to that link, let me go back to event hubs. This event hub is connected to this link, right? To this IPL hub. Now, if I send, this is the sample message with emoji. So whatever I'll send to this IPL hub event, uh, event streaming link, it will be eventually sent to the event hub. Let me come to the data explorer, and then let me send the data once, 2 3 times, and let me check it. Yes, so if you see, um, the data is present here, right? So I was testing, that's why I made 3 requests here, and we see the 4 entries here, right? So one I was testing before the demo, and that's why this one actually got. So that's how we send our data to, or we send event to the IPL hub event stream, and then IPL hub event is connected to event hub to send data, right? So whatever I discussed so far was broken into 2 pieces. Let me just help you to understand how things would be stitched together and would work on in actual during the live streaming. So uh, whatever client will send message to the group. I mean, when I say client, I'm talking about maybe the um, mobile app or the web application. So they'll send one request to the group. Whatever request they'll send to the group will see the same request. I mean, the emoji for the live streaming, as well as the same emoji will be sent to the event hub for further processing. Okay, so far we understood how to push events to um, the Web PubSub service and capture those events back to the Event Hub. Now let's jump on to the third part, that is the configuration of um, Stream Analytics job. And for the simplicity, I'll create another Event Hub because I have corrupted this Event Hub by pushing some corrupted data. If I run that analytics job on this data, it will break. So, and also I have to push multiple parallel data to run it as expected, right? And I'll close all these extra tabs now, and will make it more clear and less confusing. So let me create one more event hub. Um, Event hub for stream analytics, and let me create this event hub. So I have already captured this emoji data, which I'll push to this event hub. Let me come here. So there are multiple ways to push data to the event hub. So now I'll directly push data to this event hub. There are multiple ways of sending the data. Let me open 4 parallel tabs, and will send different data from each tab, right? Let me send this one from here. Let me send this one from here. Let me send. So we need to send live streaming data to this event hub in order to run stream analytics perfectly. Okay. So let me repeat this one. Maybe I'll take more repetition, and maybe 900. So this job will keep pushing data to this event hub continuously. All right, let me come back to the event hub and check data here once. I'll see the data pushing in here, right? So this is the live streaming data. Now going back to configure the stream analytics job, process data, and then come to the stream analytics query, and all right, it's getting refreshed and we'll see the data, live data here as well. Okay, so you can also see the live data coming in. So this is the from part. I mean, because we are getting data from Event Hub, so the Event Hub name is here, and where exactly we have to save data. This is what output we have to configure here, right? So let me create one stream analytics job. Okay, let me create through the service itself. Okay, let me change the resource group, emoji demo, game name for stream analytics job, emoji stream analytics job, review and create it. Create. Deployment is in progress. It might take some time to create the stream analytics job. Okay, resource has been created. Let me add input because we have to take data from Event Hub. We have to configure Event Hub first. All right, so this is the Event Hub and let's save it. So we also have to create a resource of a storage account because whatever data this stream analytics job um, will calculate. I mean, when I say the data calculation, I'm talking about um, the emotions, right? The sentiments will save into the storage account. So we also have to configure output as well. So this is the data we are getting from the event hub. Since we have not yet created any storage account, let me create one storage account. And then we'll configure that storage account. Emoji demo, emoji storage account 001, and then review and create. So we also have to create container because inside container only we can save files. So let's first create a storage account and then we'll create container inside it. Then inside that container only the stream analytics job will push the data. Deployment is in progress. All right, a storage account has been created. Let me create container and then let me write emoji storage account container. Now we'll connect to this container through our stream analytics job. Let's choose blob storage account container output emoji S001. Maybe it has already chosen the container inside that storage account, and let me save it. So I have already written the query which we have to execute. Let me just change the into part and from part. This query will aggregate the data and find out uh, the emojis. Uh, so what exactly this query is doing is it is taking all the data saved per 5 second, counting um, the occurrence of every emoji and saving it to the storage account. And what we further we have to do is we have to find out the emoji has maximum counts. This is what I have not done in this POC. And I mean, the purpose of this demonstration or POC was just to demonstrate how exactly each and every component is stitched together, and how flow is working end to end, right? So based on our requirement, we can also choose any SQL database to dump this data, or maybe Kusto, and then we can also run our query based on our requirement. Let me run the query. All right, so you can see that for that 5 second of window, this is the maximum count for this emoji, right? Let me save the query. Then we can start the job. All right, we keep sending the data. Job has been started. Now it will start saving data to the storage account. uh, Let me go back to the storage account. Container, this is the container, and a file will be created inside this container with the record um, uh, we'll get after executing the query, right? uh, Job has been started. Let me, okay, so we can see a file has been created, and we'll be able to see the records here. All right, so we can see for 350, I mean for that 5 second of window, we see this is the count for every emoji we are getting, and we can see that the the emotion for that 5 second of window is sad, because the maximum count we are getting is that for sad um, emoji only, right? For the second one as well, maybe this is for the next window, again the sentiments for sad is high, and for the another one is also sad one is high, right? All right, this is it from my side. I'll share the link I have used to send messages and events, as well as the documentation of Web PubSub service down below in the description of my video. And thanks for watching it.